We're in section 1.4, addressing system connectivity. Electronic systems require connections between the various components making up the system. Several methods are used. First is wires, and then printed circuit board traces, infrared links, fiber optic links, and radio links. The first one we'll look at is wires. Conductive wire is the most well-known method for providing electrical connection between electronic parts. Conductive wire is usually made of either copper, gold, silver, or aluminum. These are all highly conductive substances. And the wire is usually solid or stranded. And here we have a picture of a solid strand. You notice here we have a single conductor, and it is a piece of solid metal, and we have it wrapped with insulation. And then this lower wire, similar with the insulation, except that we have strands, many braided conductors here, rather than this single core conductor. And there are advantages and disadvantages of each, and it tends to be based on the application. We won't go there now. In Chapter 3, we'll provide a great deal more detail about the specifics of wire. For now, we're just mentioning it as one of the methods for system connectivity. Another is printed circuit boards, and earlier in this chapter we had seen this same graphic here, but one of the methods for connecting devices is through these little things we call traces. And remember, we had talked about how traces can be on multiple layers of electronic boards. Now, the thickness of these traces usually is between, we're showing between 0.007 to 0.0028 inches. That is quite thin. Now, the width is going to be a little larger. The width is typically between 6 thousandths and 0.2 inches, and you can see on this board, for example, right here, you can see that this trace is really quite wide, and then these are narrow, and sometimes they just get extremely narrow all the way down to around 6 thousandths of an inch. And then we have infrared. Many electronic systems pass data through infrared transmitters and receivers. And up here you see we have a picture of a transmitter and a receiver. And you'll see these little dotted lines here are indicating the actual infrared signal that's being passed from one to the other. And you have a picture of this in your text, by the way. Devices that use infrared include cordless computer mice. These, prior to the advent of the infrared mouse, they were all mechanical. The cordless type are quite nice because the dirt doesn't get clogged up in the little ball, and they're a little more responsive. I like them. And then we have the old television remote control, and things we call a PDA, a personal data assistant. Now, infrared devices, one of the things that identifies them is that they're often referred to as, notice this, line of sight devices, since the signal cannot penetrate walls or long distances. If you've noticed, for example, if you're using a remote for a remote TV, that if someone gets in front of you and you click it, that you simply won't get a response. Or if there's a glass or something in your way, you won't get, the TV won't respond. And that's because these are what are referred to as line of sight devices, typically short range. Though your text doesn't mention it, infrared devices usually are operating up in the terahertz frequency range. Then we have fiber optic links, another method of connectivity of electronic devices. Fiber consists of thin glass threads which have a dense clear inner core. Notice here the darker blue here is the core. This would be the actual glass. With a less dense outer covering called the cladding. And here you see this outer material here surrounding the glass is the cladding. The fiber moves data as short pulses of light, and you see these arrows here indicating the actual light moving through the glass core. The advantages of fiber optic cable is that it can carry much more data than its copper counterpart. So for years, copper has been the primary method of moving data, but they're finding that with fiber optics, we can move much more data. And it is immune from electromagnetic interference, EMI. Now, the EMI is the big enemy of copper, because with copper, when you're moving data through a copper line, and if that wire passes through an area where there's, for example, high voltages or magnetic fields, that data is subject to being corrupted. And with fiber, that data can move right through those magnetic fields or those high noise areas in terms of voltage, and it will just ignore them. And so light is immune to electromagnetic interference, which is a major advantage of fiber. And it can carry data much further without the need to re-amplify. With copper, these devices called repeaters are necessary because copper can only carry data limited distances before it needs to be re-amplified, and fiber can just carry it much, actually sometimes miles. With copper, you're talking maybe several hundred feet at the most. Now, those are the advantages. Disadvantages are that fiber tends to be quite expensive, and it is rather difficult to handle and install. It is rather delicate. Remember, it's glass. If you bend it too severely, it will break. And if it does in fact break, it is really it requires very high-end, extremely expensive equipment to repair it. With copper is relatively simple to repair, and fiber is extremely difficult to repair. Okay, radio links. Wireless communication is made possible by radio links. The RF spectrum makes possible a wide variety of wireless devices to include, and this is not all encompassing, but just a few of the things that the RF spectrum makes possible are, we have wireless telephones these days. We have wireless networks, paging systems, internet access via satellites, and many forms of industrial control are now without the need for wires. So these industrial control devices are controlled wirelessly. And I have a picture here. This is a wireless router, and this would enable a wireless network. And these operate, this particular one, about 2.4 gigahertz. And the RF spectrum, typically devices in RF spectrum are in the megahertz and gigahertz ranges, whereas infrared is way up in the terahertz range. Okay, so this section is rather quick. It is addressing system connectivity, and we're looking at how are electronic systems connected. And we just looked at radio links, and we looked at fiber optic links, infrared links, printed circuit boards, and wires.